Hi, my name is Mr. Chu and I welcome you to my channel, Mr. Chu Study Room. If today is your first time, then I encourage you to kindly consider subscribing to this channel for more videos. For some few weeks now, we have been on circuit theorems, just explaining the theorems one by one and taking questions on each. So today's study is not going to be any different. Today we are taking a question that applies one of the theorems which talks about the angle between a tangent and a chord and the relationship between that angle and the angle the chord subtends in the alternate segment. Let's enjoy the lesson together. Thank you. Today's question is from WASSCE 2021 General Mathematics paper 1, that is core mass objective test, and we are taking question 35, and it reads: in the diagram, MP is a tangent to the circle NQR. Angle PNQ equals 64 degrees and length RQ equals length RN. Find the angle marked T. This is the full question. And like I said earlier, this is the application of the sixth theorem I taught, which talks about the relationship between the angle between a tangent and a chord and the angle the chord subtends in the alternate segment where the first angle between the chord and the tangent have been formed. So that is what we are going to apply now. Let's go straight to discuss the question like we always do before we go ahead in solving. So this is where we apply the rule. As you can see, and we were told clearly, MP is a tangent to the circle because it touches the circle at N, which is the point of tangency, and the angle between the chord NQ and the tangent MP is 64 degrees. And from that sixth theorem, which is an earlier video I did, this angle here, 64 here, will be equal to angle NRQ or QRN, depending on where you are taking it from. And then, so that means the angle here will be 64 degrees. Then there is a further information that this line RN equals RQ. And we can see from the diagram here too, this means they are equal. So if they are equal, then we need to apply a little more of polygons here, that with a triangle NQR where two sides are equal, then it is an isosceles triangle. And with an isosceles triangle, the two base angles of the equal sides are also equal. So that means that if we know one of the angles, which is 64 here, then this and this are going to share the difference between 64 and 180 degrees, which is the sum of interior angles of a triangle. So that is what we are going to do. That will be 116. 116 is going to be divided into 2 by these 2, which will give us 58 degrees. And we can see that if here is 58 and here is also 58, from the same theory which we are applying here, this T here will be equal to the angle at Q, NQR, which is an angle subtended by the chord Rn, and is alternate segment to the angle between the same chord and the tangent NP. So this angle here will be equal to here, and that will give us 58 degrees. Now let's go and show that in working to see. We start by writing that angles P and Q and NRQ are equal. So let me just write that quickly. Alright. Then I also add that the sum of interior angles is 180 degrees. Therefore, this angle plus this will give us 180. So let me add that quickly. Alright. But I said earlier that this angle and this angle are also equal. So let me write that quickly. Now this implies that since this one and this one are equal, I can choose just one of them. And because this T here is the same as angle RQN, I'll use angle RQN. So so this one becomes this. Then we make RQN the subject, and that will mean 2. We divide both sides by 2. Angle RQN will give us 58 degrees. Then we now state that since angle MNR equals RQN, therefore RT will be equal to 58 degrees, which is the same as option A from our question. That is it. But then again, because this is an application question, there are other ways we can solve that will make sense. For example, after finding the 58 here, because this and this are equal, after finding the 58, we just add 1, 2, 3, which are the sum of angles on the straight line. So you see that 58 plus 64 degrees will give us 122 degrees, and 180, since the sum of angles on the straight line is 180 degrees, so 180 minus 122 will still give us the 58, which is T. So this is how we can solve this question. Thank you. I hope this lesson has helped in your understanding of the topic in a better way. If yes, then why not consider subscribing to this channel for more videos? Until we meet again in the next study, thank you and bye bye.